Well, lovely introduction about Technique. Thank you for that. My name is Rick. And yeah, we're going to talk about, we're at Blips on the Radar, which first of all is a very cool name. What is also nice about it being Utrecht is that I live in Utrecht, so I could just come here on a bike. But it's about Tech Radar, and today I'm going to talk about like a lot of specific tools that we actually use within Picnic to enable us to move really fast as a company. And one of the things that we really focus on is using automation for this to have less manual things involved. First of all, I want to show a few perspectives on this and why we're actually focusing a lot on doing this, which we will dive in a second. But why I think all of this is really interesting is because it hits a really challenging topic for large organizations that are doing software development at scale. Because maintaining a high quality code base becomes really challenging at scale. Imagine you have a company with over 20 different teams who are all doing software development. What happens is that all these teams are actually fighting the same issues. They are trying to fight technical debt, they are solving problems, and while they actually need to work on implementing new business features, they also need to establish best practices on monitoring, logging, metrics, all these kind of things. So what happens in practice is that all these 20 different teams are building their own slightly different solution. But yeah, that's a very boring and repetitive task and a waste of time. So instead of that, what we do at Picnic is we actually turn this around. There's one team who's responsible for building a module that is then reusable by all the different teams. And as a result, they can focus on actually implementing business features. So a few examples. I would like to start with a nice quote of why we're really focusing on this. And that is from Feline Hermans. Developers on average spend as much as 58% of their time comprehending existing source code. Well, as developers, we feel this. We are reading a lot more code than we are writing, albeit with doing pull request reviews or just when you're writing code, you actually need to understand a bit the context, so you're writing a lot more. And because this is a significant amount of time of our developer time, we really try to optimize for this particular part of what we are doing. It's of course a lot easier to read code that you understand because you recognize the patterns, because it's much more uniform and you have seen it before than like spaghetti-like code where everything is new and it's very inconsistent code style. Another thing where we really try to optimize is we want to limit the bike shedding and useless discussions on code styles that are happening during pull request reviews. A few examples are, hey, someone opened a PR and there's a manual comment say, hey, please use immutable list of collections.empty list. Both are doing almost exactly the same thing. It's more or less a code style issue. Another example is, hey, test methods should not be public and make sure to add the final keywords. All of them are quite trivial, and it's just to make a point basically. But we think it's okay to have these discussions, but you should have these discussions once, settle on something with everyone in the company, and then make sure that it is enforced across your whole code base. So you don't need to have these trivial discussions again, because when someone who has a really strong opinion about either of these comments, there can easily be a very large discussion about should we use method A or B, while it actually doesn't really matter, and they're actually doing the same thing. Another one is has to do with the following. Around 8 years ago, well, by now actually 10 years ago, we started using TestNG within the Picnic code base, and it's a testing library. I think most of you have heard of JUnit. And JUnit was actually a few years down the line, it became clear that JUnit was the better, with the better tool with a lot more innovation and faster moving library. So we decided, okay, we need to migrate all our test code. But at that point, we already had quite some tests. So that's, of course, quite a big, daunting task to actually do. But actually, this migration itself is not that hard. Let me show you a few code examples of what this migration mostly consists of. It's mostly moving a few annotations. So in red, we have the test in G code and the green in JUnit. The contrast is not that good, but I hope you can see it. So for example, in test in G, we had the method level test annotation, which has to move to method level. And there are some other annotations that have to be swapped out between the two libraries. So there are a few annotations I left out, but it accounts for about 95% of the migration. So you would say this is quite easy, but in what appeared to be the case is that developers weren't actually spending time on this because they had to work on more important features, and then in the end it was like, yeah, let the migration be there, we will pick it up when we have time. Well, that almost never happens. So at some point we said, how are we going to do this? Because if a developer would really love to do this and say, okay, I go to my product owner and I say, I will take 2 weeks and complete the migration for our repository, and we never have to think about this again. Well, you can imagine how the product owner would look like, because he would say, you're crazy, we have to work on this very important feature that needs to go live next week. So again, here there was a very nice opportunity to turn this around, and what we did is we had a nice summer bootcamp intern who within 2 months actually completely automated the migration, and as a result we simply could provide a script to the teams, and what they had to do is they simply ran the script, the migration did its thing, they simply had to open a pull request, review it, and it was done. And as a result all the teams could just continue with their work, and yeah, in the end we finished the migration because of that. So this is the agenda. I'm gonna give a bit more context on how we set this up within Picnic. Then I'm gonna dive into a few specific things that we provide as a platform team, basically. For example, the centralized Maven configurations, how we are reusing libraries, and then into quite a lot of tools that I'm gonna mention. And finally, I want to give a bit more insight into how we actually roll these things out within the company, especially with the tools that automatically improve code, because yeah, there can be some opinions that you need to make sure that everyone is aligned within the company. So a bit about our platform team. The idea is that we, as the title of the talk of course says, is that we want to be the enabler for all the different teams to move fast while staying aligned. How do we do that? We have 3 focus pillars basically that we use. The first of all is that we need to boost the developer productivity. This is the example I gave in the beginning. We want to have reusable coding blocks that they can easily stack on top of each other, and everything works with having to do not too much configuration. And the other one is that we want to have very uniform code base and a uniform way of working. So there has to be a lot of coding standards. We need to establish these best practices and make it really easy to follow them. And one of the things that we have is centralized configuration that works for all the different applications. And well, automation is a really important one, especially because the platform team is with only few people, and we need to be able to provide. We need to be able to support over 300 engineers within the company. So by automatically reducing technical debt, making sure that the code quality stays high, and as the previous example, we want to support with doing migrations. So how do we actually set this up? Well, we have a repository called the Picnic Java support modules. And well, within the company, there are 70 other different repositories, for example, payments, store, parcels, and for our warehouse management systems, everything. But the cool thing about this setup is that all these 70 different repositories have the Picnic Java support module as a parent. Which means that if we add one simple plugin configuration at the top, and everyone all the repositories upgrade, as a result they get this configuration for free. So we can we can have quite some impact via this setup. And well, in this repository we have a few different things. So we have the Maven parent POM configuration, which consists of about 3,000 lines of configuration. On top of that, we have the shared libraries, which we'll go over, and a lot of configuration for the tools that we use throughout the company, so that they are all configured in the exact same way. And the nice thing is that the only thing they need to do is they need to define the Picnic Java support modules as a parent. So onto the centralized Maven configuration. One of the most impactful ones is this plugin definition, where we define, hey, we are using the Google Java format, and that's a fairly strict formatter, so there are literally no discussions possible about where to put the curly bracket on the same line of the class definition or one below. It's just one way of formatting, and that's it. So the fact that there are no discussions is nice, and that it also automatically formats your code is also a very good one to have. The next one is the Maven license plugin. Especially for large organizations, it can be really hard to know what kind of libraries you are using that maybe transitively pull in other dependencies and what license they are using. Well, with this one simple plugin definition, we get a build failure if you're introducing something that is actually forbidden. And we have many of these plugin configurations, but you still need to be able to tweak how you want to build your product, your project, without having to configure every specific plugin. So what we also provide for all the teams is that there are some simple flags that you can provide. So for example, the verification.skip, if you want to do a quick build, you can simply disable all the extra static analysis and do a fast compilation. And the idea is that with having these few flags introduced, that if you're switching teams, the experience stays the same. You don't need to relearn everything about this particular project. In the Maven parent POM, there's also a large part which is the Maven dependency management section. And in this section, we basically manage the 200 core dependencies of Picnic, which is quite a lot. And they are also, the upgrades are also all reviewed by the platform team. And the idea is that by doing so, the team builds up an in-depth knowledge of all the dependencies that are being used throughout Picnic. So they know that if there's a particular Mongo upgrade, they know in which repositories to double check this and if everything is still valid. And as a result, all the different teams, they don't need to review these pull requests. They get the upgrades out of the box, and everything still works everything still works together. And of course, we don't check all these upgrades manually, so we're using the Renovate bot to actually automatically get these upgrade pull requests. I see some nodding faces, so it means that the others are also using this one, so that's good. So we are using a lot of dependencies, but we also guide the developers with making sure that the dependencies are used in a proper way. So for example, we have the Maven Enforcer plugin, and what this does is that, let's say you are using dependency A, which is dependent on Guava version 31, and you're using dependency B, which is dependent on Guava version 32. If you're using both of them, what could happen during the class path resolution is that it doesn't know which version to pick, and you can get some weird errors during runtime, for example. Well, this Maven Enforcer plugin simply checks if you have this problem, and make sure you have to fix this error. You have to pin one of the versions to be able to build successfully. Another one is the Maven dependency plugin, which checks, hey, you said in this module that you're actually using this dependency, but you are not, or the other way around. And then you can simply improve your code and make your class path smaller. So now on to the shared libraries. Within the Picnic Java support modules, we have over 40 different libraries. This goes from Spring specific, Spring security, to modules for databases, but also for the things I mentioned in the beginning, like monitoring, logging, to make sure that everyone in the company is using the same format for logging to make it a lot easier to go through the logs if you're searching for a problem. And because everything is so uniform and consistent, it is a lot easier to also contribute to other applications, because everything feels really familiar, and it's not like you want to contribute to someone else's code base, that you need to check everything and need to make sure that you need to spend some time before you're up to speed, before you can actually contribute. The idea is that it's a lot easier. And this is an example of the monitoring support. What we do is we always provide a monitoring or a config for that particular module. So if I want to use this module, which will give me some nice things, well, we, for example, use Sentry. There's another actuator endpoints, is that all the applications have that. And some other nice utilities. But if I want to use that in my application, I can simply import the monitoring config, and then everything will be taken care of for me. And this is quite nice because if you want to start writing a new application, oh, that is my next slide. If you want to start writing a new application, the only thing you have to do is you want to say, hey, I want to import the cache config, Mongo, RabbitMQ, some Webflux things. And as a result, I already have an application that nicely works together. I don't need to configure many things, and I can actually start writing my business logic very quickly. Now we go one back. And we also provide a lot of utilities to make sure that the application that you're building is working correctly, all the beans are wired correctly, but also that the security-wise, all the service methods are annotated with the secured annotations. Like there are many of these things as utilities that we provide to make sure that there's a baseline of many things, security-wise or otherwise. So now onto the section with quite a lot of tooling. First, some static analysis tools that are not doing things automatically, and then we switch to the automated tools. We're using many static analysis tools, for example, Checkstyle and SonarCloud. They are tools that can identify bugs in your code base, and they can simply fill the build and show you what you should improve. You can also nicely configure them, which rules you would like to enable. Quite a lot of people are using SonarCloud, and they mostly recognize it because it can also place comments on your pull request, because there's the quality gate thing that they have. If you are writing some new code and it introduces violations, it will basically stop the build. Yeah, we have them configured for all our repositories, and they're working nicely. One quick mention I want to do about formatters is that I sometimes hear a reason to not introduce a formatter in the code base, and that is the following: that it's because you have to format your whole code base, all the Git history gets rewritten, and sometimes companies don't want to introduce it because of that. Well, I quickly want to show this thing that you can use to work around it, because there's a very simple thing you can do. You can create a git blame ignore refs file. So you format your whole code base, do one commit, add this commit SHA to this file, and your Git history is still clean. So please, this can never be a reason to not introduce a formatter in your code base. Another interesting tool is ArchUnit. It's basically, you can define rules about the architecture of your code base. So you can write rules about your domain logic, about which classes are not allowed to have dependency on other classes in modules. You can come up with all these kind of things. And the nice thing about ArchUnit is that it has a very nice API, which allows me to read up the rule that is on the next slide, and I can simply read the code, and while I'm reading the code out loud, I can explain the rule. So it's a rule about controller naming, and it says that classes that are annotated with REST controllers should have simple name ending with, because this is the convention for REST controllers. Simple example to show you what I mean. But the more important one is the one about which classes are allowed to depend on what other classes. So here we have an example that says, hey, classes that are in our logic module should only depend on classes that are outside of the API packages. It's just an example, but you can come up with many nice things to make to have rules about the architecture of your code base. One interesting note about this one is that when you want to introduce this and you're afraid of the violations that you currently have, there is a nice thing that you can freeze the current violations to make sure that you can freeze the current violations once, and when you're introducing new violations, it will say, hey, now you need to make sure that you are you fixed it before you go on. So now on to the even more interesting part, because we want stuff to get automated for us. A tool that we've been using for a long time is a tool called ErrorProne. ErrorProne can not only find and detect bugs in your code base, but it will also provide suggested fixes for your code base. And if you run ErrorProne in patch mode, it knows how to automatically apply them in the actual source files. It's a compile time static analysis plugin. So what that means is that it compiles your code, and right after the compilation is done, it can use that additional context to do a much more thorough analysis of your code. And then it points out bugs if it finds it. It's an open source tool created by Google, and they have over 500 different error-prone checks provided out of the box. And what they also provide is a tool called Refaster. And this the idea behind Refaster is that they wanted to create a tool with which it is very easy to specify refactoring rules. So let me show you an example. How that works is that you have a before template and an after template. In the before template, you say, hey, I want to match this code in my code base, and I would like to rewrite it to the content that is in the after template. So this helps with making your code base a lot more uniform, but also with simple migrations that you can do. And the idea is that almost every Java developer is able to write such a rule because it's a simple DSL to do this. And again, this is a simple example, but once you have many of those rules, like we have over 900 of these rules, then your code base gets a lot cleaner. So internally we actually started writing a lot of these rules because we're really big fans of error-prone, and we saw really the potential of this. So many years ago, we started writing all these rules, and at some point we decided, hey, this is quite nice. We think it brings us a lot of value. So we decided to open source it around 2 years ago. And it has 950 refaster rules, but also 40 error-prone bug checks. And it also contains migrations like the TestNG to JNet migration I mentioned at the beginning. Just want to show one simple example of what an error-prone check can do. This one is the SLF4J log statement. It makes sure it analyzes the code and tries to identify, hey, when are you incorrectly using an SLF4J's log statement? So for example, this is the wrong way of doing a placeholder, so it can replace that. And here there is one placeholder for a value. And here we have two log statements, one which does put in something for the placeholder, and the first one does not put something in for the placeholder. So it says, hey, please make sure to actually do this because otherwise your log statement doesn't work. Simple thing, but just to demonstrate the idea. Then on to Open Rewrite. This is a large-scale refactoring tool. It can do many migrations. The idea is that a recipe defines one single small piece of refactoring, basically. But one recipe can consist of many other recipes. So with building a lot of these blocks together, you can do quite some large migrations. So what they have is, for example, migrate between JUnit 4, JUnit 5, Quarkus, Micronaut, migrate to Java 17 or 21. Everything is there. And one very interesting one is the Spring Boot 2 to 3 migration, because a little over a year ago, we also heavily used that one. Because this recipe consists of about 2,500 recipes. So it's a very large migration to do. But because we actually use this plus our existing technologies, we were able to migrate over 3 million lines of code in all the 70 different repositories. And that within a few weeks' time with only 5 people. So that really shows the benefits of having this uniform code base and really rely on automation. So then the last part about alignment within the company. So what we try to do with the Picnic Java support modules, about every month we do an upgrade, and we want to make sure that everyone stays really up to date, because it would be way too much to support many versions back. So we say, okay, we support 2 major versions. We always support 2 major versions, but we also really help with the process of upgrading. We want to make sure that for our customers it's really easy and there's not really a lot of room for friction, basically. So what we do is when right before we are going to do an upgrade, we do a simple alpha release. And then we perform the upgrade for all the 70 different repositories with some nice scripting and automation. And we basically perform the upgrade for them with as much automation as possible. And then we push everything to our CI. and we try to see, okay, how is this performing? We have a nice script that then creates a nice list of all the different repositories and tries to see, hey, which builds are basically green, which ones are red, because then if they are red, it means that we have to investigate what is going on there, and maybe we are introducing something that's actually incorrect, or that we should think a bit longer about it before pushing it to every team. Because if they are like, hey, you want me to introduce this, but it actually is not working for our use case, then they are basically pushing back, and we will have, well, at some point we will have problems if they keep pushing back. So because we're really going through all this effort to make this upgrade as easy as possible for them, they're actually always quite happy with doing this, and they are happy to help us out with performing the upgrade. And it's always really good to get feedback as well. So I want to tell a bit about how we went about introducing error-prone support within the company, because, well, I mentioned years ago we started with writing all these rules, but we didn't apply them all from the beginning. Well, at some point we thought, okay, now we have quite a large list of rules, but we need to make sure that, well, everyone actually agrees that they are actually correct, and that we're not introducing any bugs. And maybe we're pushing it too much. Instead of maybe we have too many rewrite rules, and people are like, yeah, I'm not agreeing. I don't think this is actually better than what we had before. So we need to be a bit smart about it, and actually collect all this input before we were creating a new version of the Picnic Java support modules that enforces all the rules. So what we did, basically the similar approach as that we do with releases, we started opening pull requests in many different repositories and started to collect feedback and try to not have too big PRs, because otherwise we would say, hey, there are now 900 rules, we applied everything on your code base and everything is rewritten. What do you think of it? Well, in the end, people would not want to review that, and that's also not what we wanted to do. So to make it a bit easier also to review and get the feedback, we splitted all the changes up in different topics, basically. And we also asked the developers to go over all the changes per topic. And the nice thing about this was, first of all, that many developers were like, okay, thanks for fixing this bug or rewriting this and making everything more clean. That was the largest group, but there were also people who were sometimes opinionated about specific rules and said like, this is not correct, or I think it should be like this or whatever. And the nice thing about doing this in many repositories is that we could see, okay, now we had like 4 or 5 different times that we got some feedback. We need to do something with it, because if we would just push for this, then it will not go through. So then we actually wrote a nice post, and we posted it on Slack in our Java channel and said like, hey, we have this situation. There are basically, in this case, there are 3 ways of writing one, and we have 3 ways of writing the exact same thing. Do you say I prefer one over the other, such that we can make this consistent in our code base? Or you don't really care, and as long as it is one of the 3 and it is enforced? Well, we used this approach a few times, but what was really good about this is that the developers felt really heard, like they were part of the decision process, and because of that we got quite some, they trusted us to perform this well, and actually that allowed us to push this through. And as a result, I can tell you that all these 950 rules are actually always applied on the Picnic code base. And one funny thing was that we actually were also able to do this on an open source repository. I already mentioned Textile, but here we basically followed the same approach. They were interested in using our error-prone support rules. So what we did is we said, hey, okay, I'm going to create an issue. These are the rules that we have. Let us know what you think about them, and then we can discuss them. And based on that, we did the exact same approach, and per check, we basically started enabling them on their code base, and error-prone support now also runs on Textile, which is quite a cool achievement. And it's nice to see that this also works in another environment. So yeah, I think that was it. I talked a lot about many different tools. I can share the presentation online after. If you're interested to hear more about Picnic, you can go join.picnic.app. And yeah, on the right is the name of our open source repository if you're interested. But yeah, that was it. Thank you for listening.